which used in the task being given by a teacher. Starting with this one. This we call Pangaea model. This is before the drifting of the continents. We have this one also. This is after the of the continental drifting of the continent. Just here also. We have this one. This will just explain about explain the cause among the cause, which is the convectional and the heat transfer, as well as this one will support the convection and the heat transfer as among of the cause of continental drifting. Also, apart from there, we have this one. This will help us to explain the centrifugal force is among of the cause of the continental drift also. Clear? Okay, thanks.
In addition, some models which you are going to use on how continental drift was formed. For example, here we use this to describe the tidal attraction and how continental drift was formed due to the tidal attraction. But also we are going to use this model. We call it Rift Valley as one of the indicators that Rift Valley, the indicator that was formed due to the Pangaea mode. But also we are going to use this material as a centrifugal force, as been explained by this. Therefore, this mode we are going to use this to describe about the centrifugal force
of landforms formation. Now we are going just to talk about continental drift. Continental drift, by definition, we can say that continental drift is a slow movement of landmass, which is caused by different geographical process, isn't it? Yeah. After there, now we have this one as the Pangaea. Pangaea. This means that before the continents to separate, or before the continents separate like this one, there was a single form landmass called the Pangaea. As you see here, this is Pangaea. But after there, this Pangaea separated into two parts, isn't it?
Yes.
Yeah, which is the southern part and the northern part. So, in the southern part, of the separation, we call it in another name. We call what? Gondwana land. So Gondwana land was the southern part of the continent after separation. We have also the northern part of the what? Of Pangaea, which is Laurasia, is it?
Yes.
Yeah, so Laurasia was the southern part after separation. Okay?
Yes.
Yeah, after the continent to separate, now we have just you can see this model. Now the continents are separated. Isn't it?
Yes.
Also, before continuing, after the separation here, now the continents have separated in, or the Pangaea have separated into two forms, or into two parts. Now the separation here, on the separation between these two, we found a narrow sea called what? Tethys. Tethys. Yeah, we have Tethys. So this Tethys was the narrow sea which separated these two parts. Also, let me go back please. Before the separation, the landmass were just surrounded with water mass called what? Panthalassa, isn't it?
Yes.
Yeah. So Panthalassa was just a water mass, isn't it? Which surrounded the Pangaea before. Yeah, after there, now we see the continents here have been what? Separated like this one. Yeah, those was the introduction of continental drifting. Now let us go directly to the causes of continental drifting. Is it?
Yes.
Yeah, there are some causes which cause the continent to separate like this. Starting with the first cause, which is the centrifugal force. This we are going direct to talk with, or we are going direct to talk about the Earth's rotation, whereby the rotation of the Earth like this led to there was the forces, or two forces. It means the southern forces and the northern forces, which were just operated toward the what? The equator of the Earth, where this resulted to the drifting of the land mass, or drifting of the continent. Another, I'm going just to talk about tidal attraction. Tidal attraction, we are going directly to talk on. Yeah, we are going to use this tidal attraction. This means that we are going to talk about the interference or attraction between the Earth as well as the moon and the sun. We have just two objects here, which is the Earth, moon and the sun. So here the interference comes whereby between the Earth and the moon there is interference or attraction, and also between the Earth and the sun there is interference, which we call here we have higher tide, is it? Yes. And here between the moon and the Earth we have also higher tide, while we have lower tides, yeah, in another side. So this also causes the continental drifting, or drifting of the continents. Another cause also we have convection and the heat transfer. We are going to use these two models, starting with the three internal structures of the Earth. We have crust, mantle, and the core. So this one, let me put it here so that everyone can understand. Okay, this one, we are going to talk about the molten materials. Outer mantle. So those molten materials are led due to the force which applied to those molten materials causes the single land mass part to rise down or to rise up. As you see here, this part of the land has lies down, isn't it? Or has bent down, while this part has lies up. So this situation of rising up of this plate causes the what? Those molten materials to come out, or the eruption of the what? Of those materials. This is enough for this model. Also, we are going just to use another model to explain the convection of the convection and heat transfer. Also, we have this model whereby this we call it crust, isn't it? While these are those molten materials, isn't it? Understand it? Yes. Yeah. These molten materials after being rising up, causes these two plates. This are called the oceanic plate, and this is the oceanic plate. So will separate due to the force coming out with those molten materials. So after the separation of those two plates, makes the space here. What is this? The space between the two plates after the what? After the eruption, I can say. This space is called what?
The ridge.
Yeah, the ridge, isn't it? Yeah. Also may support the what? The eruption of those materials through these two plates. I think I'm over there. Is it? Okay, thank you.
Thanks for increase.
I will discuss two causes of continental drift. I'll start with this tidal attraction. In this, as you can see, we have sun, S, and the moon. Here there is attraction between the S and the moon and S and the sun. So when the attraction between these two bodies, as you can see here,
Yes.
you see?
Yes.
Stop kidding. As you can see this. So when the attraction between the S and the moon, this part, water from water from here will be the S will be the virgin. Of the virgin, then the water will be deciding there will be high tides, here low tides. Since the water is coming flowing down, and at this side also attraction between the S and this part of the sun, this part of the S. Also the attraction relates to the water to here this part be getting low and this can be aside. When the attraction between these bodies, here you be high tides, since large mass of water is getting aside, and in the upper and lower there will be low tides.
Now, my question. How now these tides give evidence of the drifting of the continent? How can you now relate with this knowledge of high tides and the low tides led to the emergence of the continental drift? Who can also assist him? How? Yes.
Yeah, just listen carefully.
Okay.
We have given the model which show the causes of continent drift, is it? Before my explanation that you know like this, is the northern part, is the southern part. So this, you see that this is the sun and this is the moon, and in this space there is the water mass, and from this model we show that this water mass has in constant form, but after the arrangement of what we see here show that there is the force which attract the water mass, like let I start from here, that there is the force here attract the water which bound the S, and after this attraction in both sides cause the contraction and the relaxation of the S. The contraction on both sides cause to generate the drifting of the continent like this. Just see this. In this S is made up on 3 layers. The first layer is called what? Is called the core. The second one is called the mantle. The last one is called the crust. So in the core there is the high temperature and the pressure. So after this attraction on both these two models, which is sun and the moon, this attraction made the contraction of the S, and after that contraction, through the power, the pressure and the temperature generated here, make the angle of weakness due to the arrangements of different plates found inside the mantle. After that, cause because also the S is not static.
Thank you now. Okay, thank you. Clap hands for him, please. Okay, yes. Good. You have said one of the causes is convection. Convectional what? Convectional. Oh, convection and heat. Can you please give me who supported the ideas of the causes of continental drift? Who are the originator? Who gave that theories? Especially the causes of continental drift, the conventional, the tidal. We have how many causes? How many causes? Cause number one is called what? Centrifugal force. Centrifugal force. As what he has said, this is the model for centrifugal force. The movement, as what they have said, the movement of the cycling of the S caused much energy coming to the center of the equator. So the forces were attracted towards the equator. And due to this kind of movement, caused the equator to spread apart. The spreading apart of the equator led to the so-called continental drift. Okay? Yes. Continental drift. Now, may I please ask you, the Gondwana Range, it was formed on which side of the continent? And there are how many continents were formed on the Gondwana Range? Can you please come and describe? Gondwana Range. Use your picture. Explain. The Gondwana Range was formed where and how it was formed, the Gondwana Range. Come please.
Okay, thank you, sir, for giving me this opportunity. I will go direct to justify the parts which the Gondwana was formed according to the Pangaea map. So, Gondwana was formed southern part of the Earth's surface. And the Gondwana was formed several kinds of continents. First one here, there is Africa, there is South America, and there is Australia. And also there is New Zealand, but another continent which they are formed.
You show there, show using the model. Demonstrate using the model.
Other continents which were formed in Gondwana in the southern part of the Earth's surface. There is the Antarctica. Here there is the Africa. There is the South America. There is the Australia and the Indian Ocean. And the Indian Ocean. Okay,
Use
thank you,
that.
sir.
Use that. Clap hands for him, please.
Good afternoon, my fellow students. Okay, here I'm going to summarize and talk about this Pangaea, this large big mass which was once together with different continents before it's been split together. This was one of the biggest mass which was formed by that by the Wechner. It was one big mass which was being surrounded by a huge mass of water which was called Panthalassa, as we have seen before this one. This was the huge large mass which was surrounding the Pangaea. Then, after this big one, Pangaea being split together into different continents, it was being divided into two equal parts. The northern part, as you can see here, and the southern part. This northern part, it had 3 continents, and the southern part, it was having 6 continents. Here in the northern part, we can find the North America, Europe and Asia. These were the three continents found in the north, as you can see here. North America, Europe and Asia. And later on, Europe and Asia was split together into different. It was becoming into two. So these were the three found in the northern. And the southern, we had Australia, Africa, India, South America, and Antarctica. As you can see here from this model, we have Australia, Africa, South America, Antarctica, and this Indian Ocean. But India was very near to her. So this from there.
Okay, thank you. Good. Clap hands for him.
You see, here there is a illustration of continental drift, and here there is the explanations. By starting with here, that is Pangaea. That is Pangaea. After the continental drift takes place, okay, there is the separation of two continents. That called Laurasia and Gondwana land. Okay, and after there is after 150 years ago, so due to the separation of these countries, and today there is a countries like America, Europe, continents like America, North America, Europe, Asia, Africa, Australia, Antarctica, and South America. That is because of the different forces and others, as we see, that lead to the formation of different continents. Here we are mostly talking about the formation of landforms. So I have just a question that before the separation of continents, we had Pangaea. So this means that that land mass were all flat, or how it was looks like.
Okay, that's the question. He's asking. It was called Pangaea. Are you together? Yes. Was it flat or how it looks like? That's the question. Yes, come.
As we know, the shape of this is spherical in shape. As we know, the S is in spherical in shape. So when we talk about Pangaea, it was still there. It was still there since the S is spherical in shape, but the Pangaea, it was like this, as you can see this model, before those causes. So the shape of the S is still today in spherical shape due to the different evidence that as well let's start in O level. This evidence of spherical shape. Yes, yeah, we don't understand.
Okay.
Like that. Before the division of Pangaea, there are different continents were formed. So that after that continent were formed, there was a feature, another features were formed like valley, mountain, and so on. So the conclusion is before the Pangaea to be divided, there was I think there was a flood.
Okay, good. Thank you. Yes.
It was flat and the area was surrounded by the water.
It was it?
It was like something like Iceland and the whole area surrounded.
It was like an island.
Yes.
He is saying it was like an island surrounded with the water. Do you have? Yes, that one?
Yeah, I want to add this. It was like an island which was surrounded by huge water mass land, whereby due to continental drifting, the physical features is when they began to be formed. Not physical features were formed in. Physical features were formed due to continental drift after they break up into different continents.
Okay, good, good. Do you have any idea? Yes, good. Just speak there.
For me, I know that this was just like a plane, because after the continental drift, different physical features have been imaged, such as mountains and the basin. The basin is the effect where the landmass sink, and after thing, it means that there is just a plane, and after they are just sink, it means that the landmass before the continental drift, it means was just a plain or a plateaus, for my knowledge. Thanks.
Okay, thank you. Good. Do you have additional? Okay, good.
I'm generalized. Finishing. Okay. This Pangaya was not flat. By the earth is a sphere. So this Pangaya was an island. You know? So according to Alfred, I believe, Wigner, you know, he said the convection and heat transfer. He said that when the mantle convert the thermoconvection of heat, sometimes it be the temperature is increasing and cooling. So the way it is increasing and it is hot and cold, it forms the crack. The separation of the Pangaya. That was the.
Can you refer? Yes. Okay.
Maybe we didn't understand your question. So, can you repeat the question, then what we can ask you?
The question is there to Pangaya that was it flat before separation?
You see this? You see this?
Yeah, I see it.
The shape of this is in sphere. In spherical. Not a circle. In spherical shape. So let's assume this Pangaya was a huge landmass surrounded by water. Imagine a big landmass surrounded by water. So when you see this, let's assume this is not a Pangaya, but let's assume this landmass is Pangaya. You see the shape of the spherical, the shape of the after different causes, the being breaking up, so it was not flat.
Somehow, but not in the whole.
Yes.
Yeah, thank you. For my idea, you know that the Pangaya was spherical in shape. This is because as you refer in Form 1, you learned about the evidence of the acid sphere, that Samuel Ferdinand tried to travel along the S, but he unfortunately he found that he come to the center where he started. That is the proof that the S was spherical in shape. You know that one. As we know, Pangaya was spherical shape due to that one, due to that person Ferdinand who tried to travel, who started his journey to travel along the S, and unfortunately he met him at where he started his journey. Therefore, for my idea, but where we found that now we have ocean, we have seas, we have mountains. That is because of continental drift. Continental drift occurred, and where we found the mountain, we found the oceans, and so forth. That is all physical features we found. Therefore, generally I can say that the Pangaya was spherical in shape due to that evidence that he learned from the circumnavigation of the Earth. Thank you very much.
Clap hands for him, please. Okay, let us went down. The S, was it flat or spherical? Spherical. Was it flat or spherical? It was spherical. It was spherical. spherical. You can see, this is the S. It is a S that is hanging on space. It is on space. But think of this. There are water surrounding it. Water surrounding it. But water does not drop to other spaces because of gravitational forces. We know that. Just let come and see here. This is a solar system. As you can see, this is a solar system. This is the S, where the S is surrounded by water. But water does not move away from the S. Okay? They are surrounding, and the S is moving. So as the S rotates, go around, also water move around, but cannot move, cannot drop down on space. It is on space. So it means it was spherical in nature. But the spreading of the continent, it is whereby the continent spread apart, leading to the formations of different volcanic activities, different mountains, lift valleys, and all the features that we see emerged after the drifting of the continent. So it means before, the continent was just like a single landmass, like this one. Then after, it is drifted apart. The drifting of the continent, as you can see here, we know that, as what we said, it was just a single landmass surrounded by water. So when the continent drifted, it is where within the lakes there were water passing through, as you can see here. So this was just close to as a single landmass. But after the spreading, it is whereby this part, which became like a lift valley, a valley, it was covered by water. So the water which were surrounding this covered this open space. That's why we find Africa is very far from America. Why? There is ocean in between. The land is drifted, leading to the lifting, the valley here. So the valley, water which were surrounded, spread throughout the valleys which were left after the drifting of the continent. Okay? Yes. So the S was flat. No, was it? What was what? Spherical in nature. So the drifting causes this water to spread apart. Okay? But you can think, before it was drifted, all these were together. It means that there were no water within. Otherwise, there were inland water. But oceanic water were not there. Oceanic water emerged after the drifting of the continent. It is where the oceanic water spread throughout these areas, leading to, if you want to go to Europe, you have to pass through water. You cannot go from Europe, from Africa to Europe by using a road. Are you together? Yes, sir. Yes. Any question again? Yes. Question?
I have a question. My question, as we have discussed today, it's about the continental drifting theory. But that continental drifting theory can be proved by scientists. Is it? Who is Wegener?
Not proved by scientists. Okay, he proposed.
Yeah,
yes.
Proposed.
Yes.
So, is there any other scientist who come with his or theory, or that who Wegener is the last scientist who proposed?
Yes. A question. Wegener proposed. Are there any scientists who came up with? Yes. Yes.
There is no scientist who came up, but there are philosophers, critics and theories, and others, the explorers who explored about what they are, and the astronomers who viewed the Earth.
Okay, thank you. Good. Yes.
The other scientists who come with their proofs. That's why there's the critics which criticizing the theory of Wegener.
Example of the criticism. Can you please give the criticism so that we know that? Yes. Example
of the criticism is this theory failed to prove the centrifugal force how led to the continental drifting.
Okay. Good. Okay. And then Yes?
Some criticism we are put by have failed to explain the mechanism of continental drift.
Okay, as a causes. One of the causes is that Wagner failed to give up the mechanism for the drifting of the continent, of the causes of the drift. He said the S was drifted apart, but he did not describe the drifting of the continent. What was the cause? So the causes that we have described, which is centrifugal force, which is the tidal, are you together? And which one again?
Convectional heat.
The convectional and heat. Those were another philosophers, another scientists who proved that could be that the causes of drifting could be due to convectional forces. Are you together? Yes. Could be due to centrifugal forces. Are you together? But the measure approved, which was almost given by scientists, is through the plate tectonic, the movement of tectonic theory and the spreading theory. The spreading theory and the continental plate tectonic theory, this somehow proves that the continent could have been drifted apart due to the continental, or we are going to discuss about the plate movement, as you can see here. This is the model for plate movement, plate tectonic theory, and this flow theory. So it means that Wagner failed to describe the causes of the continental drift. So that we discussed, can you please, the conventional theory, who said, who proposed that theory? The conventional theory, the tidal theory. Who are the originator?
Arthur.
Yes?
Arthur.
Who?
Arthur Holmes.
Speak loud, yes?
Arthur Holmes.
And
Frank Bezer.
Frank? So those were naughty Wagner. Naughty?
Wagner.
That's why one of the causes is if he failed. The scientists proved that there is a failure of a jigsaw fit. What does it mean? A failure of a jigsaw fit. What does it mean?
Fitness.
Can you please raise up? Please?
He failed to prove that some continents like North America can fit in Africa maybe, or Europe can fit in Africa. The meaning of jigsaw fit.
Yes, the fitting. Good. Clap hands. So the scientists have proved that if you go through around the coast areas, the structure of the coast areas, these coast areas, some of the areas cannot fit. If you take the coast areas of North America and you bring the coast areas in Africa, if you you cross them together, if you make them, sometimes cannot fit those coasts. Why? This proves that they were not together. Though there are some who fit, like this one here. Though there are some, if you take this is which continent?
South America.
And this is
Africa.
If you make them, they fit. The coast, these are coast areas, and these are coast areas. If you make them, they fit. But there are areas which cannot fit. Cannot do what? Fit. That is why it is a failure to approve that the continent were once joined together. Yes, let's have that one. Before, yes?
I have a question.
You have a question, yes?
My question is this. There is any possibility for the continent, for the sum of the continent, to be joined once again, or to be split far away, or to remain at the same side they are?
Okay,
right now?
That's the question. Have you understood? Have you got his question?
Yes.
He is asking. Let me repeat. He asking, is any possibility of the continent which were once spread? For example, this is Europe, this is Africa. Is there any possibility of Africa to drift again? That is your question, is it? Yes. Is there any possibility? or Africa. Is there any possibility of Africa to move away from the place where it is to another place? Is there any possibility? That's your question.
Or to join.
Or this continent to join once again as a single landmass. Is there any possibility? Can you please? Yes?
On my side, I think they can, for example, Africa can just move, but they cannot join more again, once again, as the way they were.
They can join, but they cannot move. Yes?
I mean, they can, Africa can just move, but not to join again with other continents as the way they are. Since if you see the evidence which was proposed by Vietnam that jigsaw fit, some continents, if you join them again, they cannot fit.
Okay.
Yeah,
thank you. Good. Yes. Good idea. Yes.
For me, I think that no anything can happen. Why? Because anything to happen, the S experience something known as isostatic movement. So what is the purpose of that one is to counteract or to balance the state of the S. Thank you.
Good one. Ele?
No, they can't move. For example, that is a land. That is a land. It cannot move, right? Take an example. Assume this land move from one place to another. It is not a boat. So maybe it's something. Only thing that it can do, it can separate.
Can separate. Yes. Good. Yes, that one. Good.
Yes, thank you.
Speak.
Good question, but for my dear, I think that there is no any probability to form a Pangaea again, because there is a gravitational force between gravitational force at the range. So all of the continent surrounded by water, so no probability to form a single land because the gravitational force, but the single continent can form the physical creature because of many gravitational force.
Clap hand for him, please. Yes, good. Back. Yes, good. That is the good answer. Yes.
Yes, from the question, I think that about joining together, it can't happen. But in separating, for example, take for instance in Africa, it is said that this part of East Africa it can separate.
Good.
Land because the gravitational force, but the single continent can form the physical creature because of many gravitational force.
Clap hand for him, please. Yes, good. Back. Yes, good. That is the good answer. Yes.
Yes, from the question, I think that about joining together, it can't happen. But in separating, for example, take for instance in Africa, it is said that this part of East Africa it can separate.
Good. Yes.
Yes, from my idea, that one can separate. For example, Africa can separate because always we experience moon and Earth's attraction. They do attract each other. That's why, and that we have seen that was the cause of the separation of that continent into another continent. But we also always we do experience different things. For example, the cause of that one convection. Always we have molten materials. They do move. Therefore, that one also, for example, Africa. But also even that can separate. because always we do experience. For example, moon, as you have said, moon and earth is the attraction. We do experience it, and that one, the convection of magma and so forth. Thank you.
Continental drift is a slow movement, so it's something which is continual. To join is a false, but separate it can. Example: Africa, the valleys. From continent to continent, there's a valley. This is like a valley. So the way the valley are continually made in a continent, the way they separate. Thank you.
Good. Yes, that one.
Yes, my own, I think there is no possibility for the Pangea to get joined again. But I think even if you refer the series of continental drifting, it shows that, for instance, 2 million years ago, Pangea was the same. Then after 2 years, it bleak up and it created Laurasia and Gondwana, is it? Then after 150 million years later, this Laurasia and Gondwana also undergoes continental drifting, which means there is no possibility for them to rejoin again. But years to years, they undergo drifting. I think this Africa and other continents cannot rejoin again. But what's gonna happen? Few years to come, they will undergo continental drifting. That's what I think.
Yes, clap hand for him, please. Yes, good. Yes.
My question is not only for the Pangea. My question is not only for the Pangea to rejoin once again, but even for the single continent to join with the other continent. For example, Africa to rejoin with Europe or other continent over there.
So it has been answered. Now let me summarize. I appreciate your answers. Okay? The way you are answering is the way you are critically thinking. You are thinking critically. That is what I said. The knowledge that you are getting into your class, this is the class, you have to apply in the real environment. This is the real environment. You are trying now to shift the idea that you have understood what does it mean the drifting of the continent. You are trying to think now outside the class that the land that we have, the African land, could really be drifted apart or rejoined again with the other continents. That's why you are taking the knowledge from the class out to the environment. The answer is the Pangea cannot be reformed. Are we together? Yes. The continent to be rejoined again as one single landmass cannot happen. But why cannot happen? Because here we have the oceans. This is the plate, the oceanic plate. We are going to see on the next part, which is plate tectonic theory. We are going to see. We have oceanic plates and we have continental plates. So these are two plates of different kinds, even in the structure. Are we together? The continental is a silo. There is silica and aluminium. In the in the ocean, there is silica and magnesium. Very heavy. The oceanic plate is very heavy than the continental plates. So we are going to see on the part of continental plate movements. Are we together? From there, you will get more ideas on why this continent cannot be rejoined. But the next answer is the continent itself can redrift. Can it do what? Redrift. Like what happened in Kenya. There is a quake which has happened, distracting the roads and whatever. They were distracting. Means there is a valley. So a valley can happen. Even here, we are here, this is the land. Could happen a drifting of the continent one day. Yes. Are we together? Yes. Because what have said, there is a conventional movement, as what they have said. The movement of magma. Magma are always moving. Here, we have a conventional movement. This is the movement of magma. So magma are moving. This is the mantle. So there is a movement of magma. So within the crust, magma moving. there is a moving of eruptions of magma. There is addition of material on the space, which is isostatic theory. Addition, a state of balance. The S is in the state of balance. When there is one side is almost overloaded with heavy materials, one side, the other sides will be uplifted, or there will be eruptions of volcanic activities. So that's why we say a continent may drift but cannot be rejoined. Are you together?
Yes.
That is our understanding should be there. So for that case, I think we are almost through with our discussion, and I believe everyone now is very clear on what does it mean when we talk about the continent, the movement of the continent, the drifting of the continent, the causes, the effect. Is everyone aware of that?
Yes, sir.
Yes. Thank you for that. May I please, if somebody to wind up? Any somebody to wind up? Huh? Just wind up.
Yes, for my idea to end up there, generally, this continental drift has led to some human activities. Like for example, we see there, continental drift led to the formation of oceans and also seas, which now we help with the human activities, for example, agricultural activities. But also this continental drift led to the formation of mountains, which now use some people from different countries to come, and then tourism, that human activities. But also the Rift Valley, this we see there, for example, the Great East African Rift Valley, that we see that. People, they do come, then they look. So this continental rift led to the creation or formation of the human activities that you have mentioned. Thank you.
Clap hands.